Question 1 in 10b, we have a particle projected with speed u up a hill. So here's its speed u. It's being projected up a hill and there's an angle involved. The angle is beta to the horizontal and alpha to the hill. So my initial vector is going to be u cos alpha in the I direction plus u sine alpha in the j direction. My velocity vectors, my velocity in the x direction, u cos alpha minus the acceleration, which is going to be g sine beta, because you practice these, times t. The velocity in the y direction is going to be u sine alpha minus g cos beta times t, and the displacements s of x connected to u of x, v of x, is going to be u cos alpha times t ut minus, so minus a half a, which is g sine beta times t squared, and the half we'll put it there as over 2, and displacement in the y direction is going to be u sine alpha times t minus g cos beta times t squared over 2. So what we're asked for here is to show that the time of flight, the time taken to reach the max range, is 2u sine alpha over g cos beta. So that's when s of y is equal to 0. So we can say that u sine alpha times t minus g cos beta times t squared over 2 equals 0. Factoring out my t, I get u sine alpha minus g cos beta times t over 2 is equal to 0. So my initial t is equal to 0, or t is equal to 2u sine alpha, and we'd have to divide by the g cos beta that's attached to the t, g cos beta. So that's the time taken, 2u sine alpha over g cos beta, which is what we were asked to show up here. And then we're asked for the time taken to reach its height, to reach its highest perpendicular height above the hill. Show that it's exactly half the time of flight. So max height, even if we're on a horizontal, max height is when the velocity of y is equal to 0. So let's let the velocity of y equal to 0, u sine alpha minus g cos beta times t is equal to 0. I apologize for my dogs killing each other in the background. So that means that u sine alpha is equal to g cos beta times t. So u sine alpha divided by g cos beta, and I'll just rub that out, is equal to t. Now, is that half of? We've u sine alpha over g cos beta, and up here we have 2u sine alpha, so the time up here is twice u sine alpha over g cos beta. Therefore, we call this, say, t2. t2 is equal to t over 2, therefore half time of flight.